Hello everyone, welcome back to the session on electromagnetic fields and transmission lines. Today we'll continue our discussion regarding the examples on coordinate systems. Today we will see few more examples on the coordinate systems. So basically in coordinate system we consider three axes. So we have a vertical axis which is going upward, say positive z. We have one positive x and one positive y axis, but along with that we also have the negative axis, say for z, which is going towards negative, or x or y, both of them have positive as well as negative component. So these components are useful to identify the location of object. So this is the case of rectangular coordinate system. So similarly, different coordinate systems have values in positive as well as negative direction. So if we consider the spherical coordinate system, we have to consider a spherical shape. Inside sphere, we will have all the four coordinates covered. So it will be in positive as well as negative. Similarly, if we consider the cylindrical coordinate system, will have values all over the positive as well as negative direction. So before moving to example, we can revise few concepts. For example, for the dot product, if you remember, for the dot product, so these dot products are given for the coordinate system for similar direction. So here you can see, if we take dot product of similar direction ax dot ax, it will be 1. If we take similar dot product of ay with ay, it will also be 1. Similarly, if we take dot product of different coordinate directions, it will give answer as 0. So here we can see, if either we take ax cap dot ay cap, it will be 0. Even if we consider the third direction, say z in vertical, so that direction component, if we take dot product with any other direction, that will also become 0. Now what will happen if we consider cylindrical coordinate system? In cylindrical coordinate system, we have three components as radius r, angle phi, and height z. So if we take the direction component for these three, what are the three components for these three? Say for radius, it is ar cap. For phi, it is a phi cap. For z, it is az cap. So if we take dot product with any other vector for different directions, the resultant will be 0. For example, if we take dot product of, say, ar cap dot a phi cap, so its answer will be 0. But if we take the dot product of, say, ar cap with same ar cap, the answer will be 1. So what we have to remember, these are for the dot products. These rules are for dot products of the directions. For cross product, it will be opposite. That also we will see. So as we have seen for the cylindrical coordinate system, similarly we will see for the spherical coordinate system. What are the components for spherical coordinate system? Spherical coordinate system, we may have, say, r, then theta and phi. So for these three, the direction components will be ar cap, a theta cap, and a phi cap. So if we take dot product of similar vectors, say ar cap dot AR cap, it will be equal to 1. And if we take dot product of any other two, so that will become 0. The same rule is applicable for 3 coordinate system, either it is Cartesian, cylindrical or the spherical coordinate system. So let us check the cross product rules for different unit directions. So here we will consider, say, two vectors A and B. Their cross product is nothing but the third direction. Suppose vector B is going like this and vector A is going like this. So their cross product will be always perpendicular to the both of them. So if we in 3D we can see this is nothing but the plane covered by these two vectors. If we increase these vectors, then what will happen? This plane will also increase. Now if we talk about the individual cross product of their directions, so if we take the cross product of similar directions, in dot product what we have similar direction, we'll compare both dot product and cross product. In earlier we have seen, say, we may have AX cap dot AX cap. The answer was 1 for similar. Now what is difference between cross product? Cross product will be opposite to this. So if we take cross product of the similar direction, it will become 0. So here if we take the cross product of, say, AX cap cross AX cap, the result will be 0. So this difference we have to remember. Same is applicable for cylindrical or spherical coordinate system. So one more difference we will see, if we take the cross product of different direction, what will happen? Here small change will be there. So for this cross product, we will take example, say we take cross product of, say, AX cap cross AY cap. So earlier for dot product it becomes 0, but here the cross product of two different direction will give resultant as the third direction. So if we take AX cap cross AY cap, it will be the third direction, that is Z, AZ cap. The answer will be AZ cap, same like in this direction. So this is, say, Y direction, say this is X direction, and the resultant is Z direction. So this one is cross product of these two directions. That is the difference between cross product and dot product. So if we take more examples of cross product, say what will be the answer for, say, if we take cross product of AY cap into AZ cap. So what should be the answer? The third direction. So here we have Y, Z, remaining direction is X. So answer will be AX cap, right? So if we take cross product of AZ cap into AX cap, what will be the resultant? Resultant will be the answer of remaining direction. So that is, say, AY cap. So this is for Cartesian coordinate system. Same will be applicable for the cylindrical and spherical coordinate system. So that also we will see. Say we will erase this. Now we will see few more solving methods for cross product. Cross product we solve by using the matrix. We use matrix for solving the cross product. So let us consider one example. So in general, if we take this example, this is, say, A bar cross B bar. This is A cross bar B bar. Vector should have some bar on this head. So now this is vector with bar. So if we want to solve this A bar cross B bar, so what will be the answer for this? It is solved by taking the matrix of, first we'll take the directions are, say, AX cap, AY cap and AZ cap. Second line we will consider the magnitude of A, say that is AX, AY and AZ. Third one we will consider the magnitude of B, so say BX, BY and BZ, right? So this is the solution method for the cross product. So like this we can solve the cross product. These basics we have to remember. Now let us see one example. So here we have one example where two vectors are given. So vector A, x is equal to 2, y is equal to 3 and z is equal to -1, and B is equal to, say, R equal to 4, say phi is equal to 50 degrees and theta is equal to 25 degree and phi is equal to 120. We have to find out the Cartesian coordinates and distance from A to B. So let us first solve it for the radius. So let us check the solution. In solution, so how we will find out the magnitude of distance R? It will be the square root of all the three distances. So three distances are x equal to 2, y equal to 3 and z is equal to -1. So what we will get? Here we will get 2 square plus 3 square plus -1 square. So if we solve this we will get 3.742. Say first we find out this R. Then we can find out the theta by using the formula we discussed in the previous session. By using simple trigonometric law we can find out. So here theta is equal to, say, cos inverse of -1 upon 3.742. This is our R. So if we solve this we'll get theta is equal to 10.5 degrees. So this is theta. Now for spherical coordinate we have to find out. So third angle we can calculate as phi. So here we are converting the coordinates from Cartesian to spherical. So phi will be equal to tan inverse. So opposite by side we have y axis 3 by x axis, that is 2, and this value will be equal to 56.3 degrees. So this is our second angle. So this is answer of part A. We have the spherical coordinates. So next we will see, next part we will, so here we will erase it. Okay, now we will see solution for the next part B. So for solving B part of the question, the Cartesian coordinates of B we have to find out. So first, for finding x, what we can use, the simple relation. So we have 4 sine of, R is 4 sine of, and theta is 25, R for sine 25 degrees cos phi. How much phi? Phi is 120 degrees. So if we solve this, we'll get minus 0.845. This will be the value of x. Now one point we have converted into Cartesian. Second one we'll consider for y. So y, how we will find out? We'll find out in place of cos we'll get only sine. So here will be 4 sine 25 degrees, again sine 120 degrees. So what will be the y equal to? So after solving this we'll get 1.464. Now third one, to calculate z. Calculate z is even simple. We'll take 4 cos 25 degrees. That's it. So this is for z. So after calculating this we'll get z equal to 3.625. Now this is answer for part B. Now let us see for part C. Part C we have to find out the distance from A to B. So for finding distance A to B, what we will do? We have to find out distance from A to B. For that, A and B, both coordinates, we have to take square root for them. So first, what is for A, x is 2 plus second coordinate for A is 0.845, so whole square, plus similarly second one is 3 minus 1.464 whole square plus minus 1 minus 3.625 whole square. So after solving this, we will get answer as 5.643. So this is solution for this question. So now let us move to next one. Before going to next one, we have to see some relations we have to remember for the transformation of a vector from Cartesian to spherical and vice versa. So here we have to remember, if we take the dot product, here we are taking table for the dot product of AR and AX. Now these are two different coordinate systems. So if we take two different coordinate system and their dot product, so this product if we take between AR and AX, the answer will be sine theta cos phi. So like this we can solve this example for problems involving transformation between, what is this? These are Cartesian coordinate system and these are spherical coordinate system, right? So if we take dot product between A theta and AX, we have to solve it by using cos theta cos phi. If we take dot product between A phi and AX, we have to use minus sin phi. Similarly, if we take dot product between AR cap and AY cap, we have to solve by using sin theta sin phi. Okay. So similarly all. There again one more thing we have to remember, dot product of AZ and A phi will be 0. So by using this table we can find out the solution for the given examples. Now let us consider one example. So here we will take one example, transfer each of the following vectors to spherical coordinates at the point specified. The first one is phi AX cap at B, R equal to 4, theta equal to 25 degree and phi is equal to 120 degree. So how to differentiate between cylindrical and spherical? In cylindrical we don't have phi. In place of phi there will be z. So now we'll solve one by one. First let us consider example A. For solving example A, so we have point phi AX is given. There is no y and z component. So what we can say let A bar is phi ax cap. So we can write it in terms of, say, AR, magnitude and direction, plus A theta, magnitude and direction, plus A phi, this is magnitude and this is direction. So from here what we can say, we can solve for different values, magnitudes. First say what will be AR equal to, so AR will be equal to, it is nothing but A into AR cap. So for solving this we will take the dot product, phi is only with AX cap. So this is AX cap product with AR cap we have to take. So what is the formula for this? So this one we can solve by using, this will be equal to phi, according to our table this value is sin theta cos phi, right? This is for AR. So for A theta, it will be equal to A bar into A theta cap. According to our table we can solve it as, say, phi AX cap dot A theta cap. This can be solved as phi cos theta cos phi. And third one is, say, A phi. So we can have it A bar dot A phi cap. So it will be equal to, this can be solved as phi AX cap dot A phi cap. So for this formula is, we can use minus of phi sin phi. So if we keep all these value and solve it, we'll get the A bar at point P. So we can keep the value of theta and phi for A. So we'll get, I will erase it. So we'll get A bar is equal to phi sin theta cos phi AR cap plus 5 cos theta cos phi A phi cap. Then so this is A theta cap minus phi sin phi A phi cap. So for point A, if we keep the value of theta and phi, we will get minus 1.057 AR cap minus 2.66 A theta cap minus 4.33 A phi cap. So this will be the solution for part A. So part B will solve. Part B is asking same point phi x cap, but here we have to keep the value of x, y and z like this. So for solving part B, R directly we can take the square root of, so first let us solve for R equal to, so R will be equal to square root of, say, first x is 2 square plus y is 3 square plus z is minus 1 whole square. So if we solve this, we will get 3.742. The same way like we did in last example, theta will be equal to cos inverse minus 1 by 3.742. If we solve this, it will be 105.5 degrees. So phi we can solve by using tan inverse. The x is y, the x is 3 and y is 2. So if we solve this, we will get 56.3 degrees. Now if we keep these values in the whole vector equation, what we will get? So we can write the whole answer as A bar is equal to 2.673 AR cap minus 0.741 A theta cap minus 4.16 A phi cap. So this is the solution for part B. Now we'll solve for C. C question is 4ax cap minus 2ay cap minus 4az cap. We have to transform for another point P given at this location. So let us consider it as vector B. Let B bar is equal to, it is given as 4ax cap minus 2ay cap minus 4az cap. So this one we can solve. We can compare it with the spherical coordinate system as, say, BR AR cap plus B theta A theta cap plus B phi A phi cap. So one by one we will solve. So let us first consider for BR. So BR is equal to, so it is, this is BR, vector into direction. So this is equal to, we have 4ax cap minus 2ay cap minus 4az cap, and the directions are, here we have to add the direction. What are the directions? The direction for this is, say, AR cap, BR AR cap. So we have to take dot product with these three terms with AR cap. So if we solve, what we will get? We will get it as, say, this one, for this one, 4ax cap dot AR cap minus 2ay cap dot AR cap. Then next one, minus 4az cap dot AR cap. So if we solve this one, what we'll get? You can try it yourself. Here I am writing the solution for this. We'll get 4 sin theta cos phi minus 2 sin theta sin phi minus 4 cos theta. So this is for BR. Similarly, we can calculate for B theta. So B theta will be equal to magnitude into direction. So again, same way, we have 4ax cap minus 2ay cap minus 4az cap into direction A theta cap. So one by one we will take the dot product. First we will take for 4ax cap. So we will get 4ax cap dot A theta cap. Then we will take with this one minus 2ay cap dot A theta cap. Then third one is minus 4az cap into E theta cap. So this will be equal to, after solving, we will get 4 cos theta cos phi minus 2 cos theta sin phi plus 4 sin theta. Similar way, we can get the value for B phi. So I will write direct solution for B phi. So B phi in similar way will get as minus 4 sin phi minus 2 cos phi. So here we can find out, so like this we can find out the solution. So similar way you can solve the remaining parts by using same methods. So next session we will see few more examples. Till then, have a good time.